School at France Paris La Défense, and I am member of the DSC Research Center Laboratory in Paris too. First, let me begin by thanking the organizers and the committee for inviting me as keynote speaker to present my research work in this 5th International Conference on Smart Technology in Data Science and Communication. Thank you very much. I will start to present briefly my research laboratory, the DSC Research Center. Our laboratory, focused on the innovation and the digital technology, is structured with 4 research groups and partnerships units. Then we have digital group, business group, finance group, and the modeling group. I work in the digital group, where the main research axis focuses on the digital transformation in the era of the big data. This research group is multi and cross-disciplinary, from computer science, management, and finance. The digital group is composed of 4 topics, from big data to smart data, in which I belong, the business and digital, smart industry, and the last one is the computer-human interaction. My axis from big data to smart data is focused on the data mining, machine learning, and big data process studies. In this topic, we main especially in collecting, storing, analyzing, optimizing, and presenting the data. In the context of the big data, the amount, the diversity, the veracity, and the velocity of the data make the raw data inexploitable. Then our objective is to rethink the traditional data mining tools and the way in which information management is approached. When we designed solution, then we designed the solution that take advantage in knowledge presentation, scaling techniques, data manipulation, machine learning, and data mining. In our access from big data to smart data, our studies analyzed and research are given to application in the tourist file. Then the question is why we choose the tourist files as a domain of application. And then thanks to the advance of the digital tools as social network and the mobile internet technologies, the amount and the diversity of the e-data from the pupil are growing. Then we have collected over the years a lot of data through the social networks like Instagram, Facebook, TripAdvisor, Booking, etc. For example, actually, on TripAdvisor, we have been collected data since 2010. Then we have a huge data set of the data in social collecting in social network. In this social network, people tend to share openly and frequently photo, video, review, recommendation on their travel, on their trip, and they share their experience. We get a huge data set composed of information then about the user, like nationality, gender, age, and we have information about the place visited by this user. In front of the large and the huge ocean of the data that waiting to be explored, our research are focused on several axes. The first one, from which the others are dependent, is the scraping and the storing of the e-data from the social network will all the metadata and use it from the experience of the travelers. Then we use the data mining to detect, for example, frequency item as tendency and seasonality. This studies mean to build recommendation tools for a tourist manager, for example. Another topic using of the data is to detect segments of tourist behavior, including their personal information, visits, movement, trip, and when and where they travel. Then we can note for various social networks like TripAdvisor, people left their personal opinion and experience as a review. This work meant to determine the sentiments analysis of the tourist about an experience for local tourist office and managers. And the final acts, we work also on the circulation and propagation of the tourist in a given area. The object is to detect tendencies or impact of the tourist area over its neighbor. Then, this is an overview of the topic and the axis research carried out in the axis of the big data from big data to smart data. Today, the work that I present is about the last student on the new measure for tourist segmentation that represent a good and useful application for this dataset knowledge extraction. We present a new way to handle tourist database and how to analyze and understand common tourist behavior. The work that I present today have been submitted and accepted on the International Conference API Web, then Web and the Big Data 2022. The motivation of this work, then the tourist actors such as tourist office, cultural and commercial services analyzing the behaviors of tourists to know their motivation as segments, to adapt their demand and then help them to make a decision. The segments are typically determined by survey and polls. However, the emerging of social networks such as TripAdvisor and Booking has created a new paradigm for the study of tourist segmentation. The main objective of our work is to find a new measure which fit with the tourist file that can be used to analyze the huge data left by the tourists on the social networks. This measure is used to determine the tourist segmentation using clustering algorithm. In this presentation, I follow this outline. First, I present the definition of segmentation and the main difference between segmentation and profiling. Then I present some related work about the segmentation, followed by our approach and our new measure, tourist segmentation measure. Then we show the experiments results of our measure applied to TripAdvisor dataset to finish with a conclusion and perspective. First, let me define the notion of segmentation and how it's different from the profiling. Tourist profiling is the process of defining the ideal tourist based on a set of unique characteristics. This includes information on their demographics, behaviors patterns, geographic location, and interest. From the profile, one can find similar pupil can determine common characteristics and divergent ones. We can consider profiling as supervised method as we already know the characteristic we based the upcoming profiling. On the other hand, the tourist segmentation is all about splitting our existing tourist pool into more specific subgraphs. Each of these small groups, this subgraph, shared unique characteristics based on information collected from existing data. This method is closer to unsupervised method, since we do not have any idea of the segment of the data set. Then in our work, we studied tourist segmentation and not profiling tourists. Tourist market segmentation is the tactical instrument to get a clear picture of the heterogeneity and commonality among potential tourists. Tourists have different background, preference, aspiration, habits, and sensibilities, of course. Then the trace left by the tourist on the social network make it possible to identify them and extract typical segments. In the literature, there is different segmentation criteria. We can cite 5 basic segmentation We have geographic, demographic, psychographic, and behavior. In the geographical segmentation, the tourists are divided based on the geography, such as the region, city, country, topography, etc. These criteria are based on the assumption that people in the same place can share characteristics such as lifestyle and the habits. The second type is demographic segmentation. This one separates tourists based on their gender, lifestyle, family structure, ethic, etc. An example of this of marketing segmentation using the demographic may be the development of channels like 18-25 old for the age, for example. The third criterion is psychographic segmentation. This one takes into account more strongly the psychological composition of the tourist. In this category, we gather the information about the lifestyle, personality, values, interests of the target tourist, considering that the tourists in the same demographic segment may have very different psychological profiles. And the last one is the behavior segmentation. This one distinguishes tourists based on their consumption habits, such as the frequent or the composition of their state. This segment also takes into account seasonality as the travel habit of particular group. For example, in the Europe, the travel are expected to construct their long trip during the summer because the vacancy period in the summer is longer. In this study, we will focus on the behavior segmentation using the network dataset. In the literature, many studies have proposed and existed in data-driven tourist segmentation methods. However, few of them try to adapt their method to the tourist specificity. And the most used concept for the social network analysis, which lead to tourist indicators, are based on the segmentation variables or unsupervised learning model. When the empirical data is considered, then the segmentation variables need to be selected. Their choice greatly depends on the method's objective. Here we have just pointer. Here we have the two in literature publication about the segmentation. The first one is about the segmentation based on the review of the tourist, and the second one about the localization of the tourist. In this case, the segmentation variable obvious different from the ask of the purpose objective, such as if it is impossible to propose the set of segmentation variable suitable for any situation. Then they are pointed in the literature by Dorsey in this publication that you must justify the provide of their choice of this variable. Then this is the one first problem. Based the justification, another problem concerning segmentation variable is the type of side variables. Indeed, in the variable types directly impact the clustering process because the majority of the method have opted for the numerical variables as the segments variable, resulting in the loss of the information containing within categorical variables. Then, commonly in the literature, the way to handle categories variable is to convert them into the numerical variable by the means of encoding. However, this practice is not recommended in the clustering context, as arbitrary numerical values will distort the distance computing between the instances in the clustering algorithm. The second method in the literature is unsupervised learning method. Then the data-driven segmentation studies have proposed both model-based and not model-based. The model-based are almost always a part of the recommendation system, as they use a writing feature to construct three-dimensional matrix user writing object to perform collaborative filtering. The scope of this student differ from our desert based on segmentation on actual behaviors features such as point of the interest visited by the tourist. The second model is the no model based method. This one used most of the time either, for example, the K-means or the hierarchical algorithm. The choice of an unsupervised learning model is part tied to this of the segmentation variable as presented previously. In each model, my trait data type differently from another one. As pointed on the literature, data-driven tourist segmentation students have almost never used the mixed data clustering algorithms to perform their segmentation. To tackle this issue, mixed data clustering algorithms have been proposed, such as partitional algorithm, hierarchical algorithms, and the last one is the neural network based. Then, based on the advantage and the disadvantage of the literature method, we propose a data-driven tourist segmentation method with following some properties. First one, our method is hybrid data collection method. Our measure suitable to a massive dataset because the huge dataset, relevant segmentation variable according to tourist context, and our method mixed data clustering algorithm designed to fit tourist particularities. The flowchart of our method is presented in this figure. Then our method is made up of two parts. The first one is the data processing, and the second one is the method, where we have our measure. The purpose of our approach is to use the digital draft to first understand the tourist behaviors and secondly segment tourists based on their behavior. The proposed approach is composed on the two steps in addition to the data processing. Here it's the first step, and here we have the second step. The first step consisted to assign states to the cluster based on their similarity using our measure TSM, tourist segmentation measure, and make the clustering algorithm. The second step is to considering the state cluster, then the cluster result of the first step, to construct a tourist segment and then retrieve information for them. Then the first part is the data processing. We will focus on the study and the analyzing of the tourist segmentation through the digital trace left by the tourist on the social network. The digital traces refer to the digital data left by the tourist voluntarily on the social network. The tourist data containing information about the tourist, about the place visited, and the interaction between the tourist and the place when we write, for example, the review. A tourist is defined by personal information like the age, nationality, gender. He visits during the stay some places. Each place is characterized by the name, or coordinate, longitude, and latitude. The type of attraction, for example, hotel, restaurant, monument, etc. And we write some review. Each place was aligned with administrative area, GIDM. Then it's an alignment used in the word to classify the place. Then we have some information about the data. Based on this digital trace, we create the stay of each tourist. Then the question is how to define this stay. A stay is defined as the movement of the tourist from the moment he leaves his residence until he returns. Then during the travel, tourist makes succession of the stays. Here, for example, he visits some places in different countries, for example, of various duration in different places. Each state is chronological succession of the place visited by this tourist. Then we build a set of states. We will relate on the review left by the tourist on the social network. I explain. When the tourist stay is a success of the day where he published at least one review per day. For example, when he visits the first place, we make one review, the second one will make at least one review, etc. However, a tourist may not post it for a limited period of the time during the stay. There is not a review. For example, here we have one day the tourist do not publish any review. Therefore, we considered a maximum number of possible days in break before as considered as 7 days according to the literature in Gosling. Then, for example, if the data break between two trips is less than 7 days, we can combine the first trip and the second one as one stay. Then we use this equation to combine the trip in a stay. The result of this process is a set of stay that we use to make segmentation. That we just note that tourist behaviors and decisions are influenced by a set of external parameters that we can call contextual factors. Contextual factors refer to the general environment in which the tourist operated, such as season, weather condition, duration of the visit, social factor, etc. Contextual factors are not explicitly contained within the digital trace, like, for example, the nationality, the age, etc. Therefore, we will enrich our data in order to exploit this contextual factor. Then for each tourist stay, a set of contextual factors are associated with it. This contextual factor can be of two types, push factor and pull factor. The push factor causes the tourists to live in country. They include the natural motivations such as desire to enjoy a different climate, institution motivation as school vacancies, etc. The pull factor attract tourists and relate to the desire to the destination area. They include, for example, the climate, the cultural event, or sports seasons. To study tourist segmentation, we will focus on the insensitive and attractive factor that can be computed during using the metadata of the reviews and metadata of the reviews and of the place visited by this tourist. Then we choose the two parameters to included in our study, the seasonality and the length of the day. This seasonality is an insensitive and attraction factor for the tourist. The duration of the stay is calculated using the equation in the presented previously. Now we have a data set composed of the stay. For each stay, we have information about the season where when the tourist make this stay, and the duration of each stay. Now we focused on the place visited by the tourist. then we're going to focus it on the content of the stay. During stay, tourists visit various places such as museum, monuments, historical places, religion places, etc. In the context of the tourist segmentation, we are not interested in the place visited as entity, but as structure. For example, one tourist visit Eiffel Tower. We considered that he visit a monument. The name Eiffel Tower is not important for us. Then we will classify tourist place into categories based on an ontology. To make this ontology, we have been inspired by the literature studies and the classification system of various social networks such as TripAdvisor to propose ontology on two levels. The first level will be composed of the six category, and each category is composed of the subcategory which differ from one category to another one. Then each class belonging to at last one category and one subcategory. We can note that class can belong to several categories and subcategories. For example, some monuments belonging to the category heritage, for example, and to the category cultural building. And it should be noted that this classification might be done by hand, by experts, to refer the, the complexity of each classes. Sorry. Then, after having detailed the creation and enriched of the stay dataset, we can present our measure. Tourist segmentation measure TSM must handle mixed data and leverage tourist experience, and is computed the distance between two stays, based both on the context and content factor. Our measure follows two properties to be defined as distance. Each distance must respect the property of positivity, or distance is positive, and symmetry. Our measure, additional of these two properties, we have another properties to define our measure as a metric. The first one is the triangle property, and the second one is reflexivity. Then this measure TSM respects the four conditions. Then our measure can be defined as measure distance metric. As stay is defined by its context and contents, our measure between TSM between two stay can be seen as the addition of the context distance and the content distance. We have two hyperparameters alpha and beta belonging interval 0, 1 with this where their addition is equal to 1. These hyperparameters are used to weight the influence on both components. Then let me remind that the context of stay is composed of the duration of this stay and the season, while the content distance of stay is composed of the set of weights based on proposed ontology. We call this proposed ontology classification vector. Then here we have the two equations to calculate the distance context and the distance content. We detail these two distances. The context distance then is composed of the duration distance and the season distance. The duration distance between two stays is the Euclidean distance, where here the delta, if we have I and B, delta I and delta B, the duration of the respective stay is stay I and stay B. The duration distance can be computed on a normalized set of the duration to avoid the big result. It's important to normalize our distance. We based our season here, our season distance on the calendar. For example, in the French calendar, like other country in the Europe, is divided into 4 seasons: winter, spring, summer, and autumn. As the seasons are cyclic, we can represent them in graph where seasons are the node. Those nodes are connected if the corresponding seasons are consecutive. Then we have 0 if the stay make in the same season. If we have the adjacent node, for example, summer and the autumn, we have the values of the distance is 0.5. And if it is not connected directly, for example, winter and summer, we have the values of 1. Now we explain how to compute the content distance. The content distance is computed thanks to the classification vector based on the ontology. Then to remind that the ontology is composed of the 6 sub-vectors containing the number of every places categories visited during the stay. We compute the distance between the two classification vector as the sum of the cosine distance of each sub-vector 2 by 2. Here in the following example, we compute the content distance between the first classification vector and the second classification vector, for example, stay 1 and stay 2. As shown, the cosine distance between an empty vector to another one is equal to 0. For example, here we have an empty vector. And when we have two subvectors like in the line 2, that present a similar distribution, the cosine distance is equal to 1. Then here we have just an example to calculate the cosine distance component using this cosine distance. Sorry. The content distance have a range from 0 to 6 in the term of similarity. Then now we defined our measure, TSM measure. We have our data set, we have our measure and the H composition of this measure. Now we can present the final step concerning the clustering process. Then, first, we construct and compute the distance matrix between the states contained in the dataset. Here, this one is an example of distance matrix. HC here is the values distance between, for example, here we have the state D and the state C. That here we have the tourist segmentation measure TSM distance between this state and this one. This matrix, of course, is symmetric due to the distance properties. The distance matrix is used as the input of a clustering model to deduce the cluster from it. These clusters are analyzed to determine clustering quality than the segment. Just to note, in this example, all the values in this matrix is integer, but in the reality, we can have positive real data, not just an integer. Now we have the input as matrix distance. We select algorithm clustering algorithm Agnes algorithm as our clustering model. We note that other supervised learning models could be performed working with the rest of our approach, and we will be extensively discussed in the future work. Agnes is based around the successive emerge of the clusters based on the distance matrix. Each state presented in the distance matrix is initially considered as a cluster. At each step, clusters are merged depending on the proximity criteria. To compute this proximity criteria, we use the linkage method. In this case, we use the Ward method. This is the equation to calculate the linkage method. The Ward method to determine the proximity between clusters. Then we use the Ward method to determine the proximity between clusters in order to merge them in the hierarchy clustering process. This Ward method is based on the minimization of the total within clustering variance, which is the relevant criteria if trying to discover compact cluster. This is the condition, the equation condition to make this minimization. In order to evaluate the compactness, the connectedness, and the separation of cluster partition, internal measure can be used. Then here we use a silhouette index, which only the silhouette index required a distance metric to function. Once the clusters are computed, we summarize them to retrieve knowledge, especially in order to see if some clusters match already well now resulting from tourist management and what existing in literature. Firstly, by using the static information of every tourist whose stay are represented in the given cluster, then we enhance the cluster with demographic and geographic information. Then for each cluster, we project the information about the tourist. For example, the name, we have not name, the age, the nationality, the gender, etc. Then we compute the percent representation of both context and content information in cluster. Then here we have this 7 description of the knowledge extraction of each cluster. The clusters summarized are the finality of this method, synthesizing all the information contained by the tourist and their stay, whose content and context tend to be closer to each other. These summaries are analyzing to extract information about tourist behavior that can be compared with the past research, the result of the literature, and to challenge the existing knowledge boundaries. In addition to a summary of each cluster, a global summary of the whole data set is built. Now our method is applied to the data-driven tourist segmentation approach to the city of Paris, the capital of France. Paris is one of the most attraction cities in the world, regularly rising to the top of the most visited cities in the world. Another reason why we should to study the case of Paris is the potential profile diversity in the French capital. In the conducted experience, we have a dataset origin of TripAdvisor during 1 year, 2028. Then we have some review written and posted by this tourist in this year. This review have been posted for a ration about 2.7 review per person. And we have 14 nationality. When we apply our algorithm to generated state on those review, we resulting 11,360 state. At this point, the hyperparameter alpha and beta need to be set in order to generate the distance metric. Then, by considering the couple alpha and beta with step 0,1, we obtain time coup. Then here we have the parameter beta, and here we have the parameter alpha. Then the gap between each values is 0.1. Then rather than computing our method on each of them, we only related retrieve couple that results are different enough. To do so, we compute the entanglement factor between each couple endogram. 100 endograms can be compared side by side in order to analyze relevant difference and the entanglement factor, which range of 0, there is not entanglement, and 1, there is full entanglement. And this operation indicates the quality of the alignment of two dendrograms. Thus, a lower entanglement coefficient corresponding to the better alignment. Here in this figure, we can see clearly present of two plateaus, one and the second one here. Then we retain the following couple: for one for the for this region, another one for this region, and two for the extern values, one here and one here, and the last values is the intermediate values we select here. Then just for each of those couple, we compute the distance matrix is a two-dimensional symmetric square matrix with this dimension of our matrix. To justify the relevance of our method's result, we compare them with other three famous supervised learning algorithms. Then we have K-means, Agnès, and K-prototype. And supervised learning algorithms take two variables in input, then the distance matrix and the number of the cluster. As the state dataset of the three benchmark algorithms and the 5 distance matrix, then here is the 5 distance matrix with different alpha and beta hyper parameter. Then we determine the number of the cluster for each of this method and for the database by minimizing the silhouette index. We obtain clusters that can be summarized and compared to the tourist management past studied to compute how many segments determined by the tourist management study are found by the model in their respective cluster. But we cannot then, since the tourist manager compare their segmentation by nationality, and we have 14 nationality, then we choose this measure with alpha 0.8 and the beta 0.2 because we have 14 segments corresponding to the 14 nationality in our study. We can note since a cluster can contain various nationalities, then a cluster can validate multi-segments. We can see here in Paris, the case of Paris, but is not the case of other country. The number of validated segments content of the state is less than the alpha, the parameter beta content of the state is less important by the context because the values of the first hyperparameter is 0.8 and the second one is 0.2. Donc, in case of the Paris, the context parameter is more important than the content parameters. Here we have an example just for the TCM 0.5, 0.5, because we have 6 clusters, just to show the result. And we present how to validate this cluster. This table presents a statistic about the cluster for TSM 0.5, 0.5. Similarity, the information about the tourist demographic and place visited per tourist is available in each cluster summarized by the projection. Then here we have the cluster, the information about the duration, about the number of the review, and the number of the tourists in each cluster. The following slide will briefly show the result. We will argument about each cluster later. Here is the place classification summarized per cluster, only with the TSM 0.5, 0.5. As we can see, the distribution of the place among the cluster varies greatly from one cluster to another one. For example, in the cluster 1, we have a huge portion of the musical building here. Compared to, of course, to another cluster. Similarity, the cluster 4 here, we have we will present more watering plus this one. Yes, this one then is more watering plus than the other cluster. But referred to only the plus, we do not give onto information to compute this segmentation. Then we have here the nationality distribution summarized per cluster. It's the same cluster. Here we have the 6 cluster, and here we have the 6 cluster. Here about the distribution of the place, and here about the distribution of the nationality. We can see some cluster as the cluster 3 and 5, a huge portion of the local nationality, like people from France, Belgium, Germany, or Spain. To perform a segment, we will combine the result from the table of presented above, and the two figures to extract common behavior of the cluster. Here, we analyze just one cluster. We choose the cluster 3, but in our study, we analyze each cluster one by one. We can see here in the cluster 3, two nationalities are overrepresented. We have the French nationality and the United Kingdom nationality. One nationality is underrepresented, United States, American person. If we take a look at the American reports, we can confirm that the American tourists visiting Paris are uninterested in amusement park, unlike British and French tourists. Additionally, stay in this cluster here, then cluster 3, have the shortest average duration due to the geographic proximity between French and British tourists to Paris, and the fact they only spend their stay in the amusement park, the hotel, the restaurant, etc. This king of the tourist only represented in the dataset 7.6% of the tourists of Paris. To validate the segment, we must analyze all clusters one by one and compare them to the past and the referent website, past study and the referent website. Then I conclude my presentation. We have presented a method to efficient segment tourists based on the data-driven method that proposes an innovative way to comprehend the tourist industry and adapt clustering algorithm to it. Our experiments demonstrate our result validity by matching with the tourist management report. We also provide our methods superiority by performing better than traditional clustering algorithm. Our method is both reliable and effective. The tourist industry can exploit our method extensively by past tourist management studies. Since our method required nothing but just digital trace, it negates the complicated and expensive framework for the tourist management study. In the future study, we hope to include more information about the tourist profile, particularly to the demographic profile and to stays. And we will evaluate our approach in another geographic area, for example, New York or any other place in the world, to compare the result obtained and the impact of the pandemic on the tourist. Thank you for your attention, and if we have questions.
Professor Sonia, can you hear me?
Yes, I hear you.
Okay. So it's a nice presentation. This is Devnath Bhattacharya here.
Thank you.
It's a nice, not only nice presentation, the concept is very new to the society. And
Yes, because in French we have some cities in Paris, for example, the manager tourist in Paris, we're looking for the segmentation of the tourist of the tourists. This study is made according to the demand of the Paris municipality.
right. So you are getting good result on it, I think.
Yeah.
So it can be used any good tourist city, not only Paris,
Yes.
maybe.
Here I present just Paris, but we use the information first in different cities in the Paris, and we
Yes.
make this in the New York and in London.
Right.
And the objective is to make this in all the world, and we have the profile of the tourist in the world. But we have the information about the context of, for example, the season of all country in the world. There is 2 seasons, 3 seasons, 4 seasons. We adapt our algorithm to the number of the season, for example.
One more, my interest is that. So it is actually, I understand that it is tourism segmentation. So when it is the data already segmented by the tourism segmentation concept, then what is the use of the different clustering algorithm again using with the tourism segmentation? That I want to know. Is it required or it will give more better result?
In the study, we after having our measure, the TSM measure, we can use different algorithm. We chose here to use the Agnes algorithm, but in the experimental we use different algorithm and we compare all the results to say if there is an algorithm better than other one. And the conclusion is the algorithm, when we show the hierarchical algorithm, the principal difficult is to show the measure. When we show the good measure, we can have the same result with different algorithm. But when we make, for example, just Euclidean distance or cosine distance, just this one, we cannot have all the summarize of the cluster and make the segmentation.
Right. Okay, very convincing work, madam. So I want to use this in our area also in like New Delhi, Mumbai, like that,
Yeah,
Kolkata
yes,
kind of cities.
yes,
Yes.
yes. I can test for these cities because in TripAdvisor we have data since 2010 over the world. We have data about Indian, American, China's, all person. But we have not the identity, for example, the name and the surname of the person, just an identify and the nationality. Like I can apply this segmentation, for example, for New Delhi, and we have type of segmentation if you want.
Right. Great, madam. Thank you very much.
Thank you.
If anybody has any researcher, I think will get interest on this type of new concept. Is really convincing. If anybody want to work or anybody has any kind of query or try to understand, please communicate with Sonia madam now. She is
Yes.
available now. So
Okay.
I'm requesting other people.
There is my address mail. If you have any question or any request, we can contact me.
Right. Okay. Thank you.
Thank you. Thank you very much.
Welcome.
Thank you.
Participants, if you have any questions, please raise a hand so that you can ask the professor.
Thank you, Professor Jawali Sonia. We are grateful for the time and effort you took to share your thoughts and experiences. Thank you.
Okay, thank you very much.
Your screen is visible, sir. Sir, your voice is not audible, sir.
So, good afternoon to everyone, and our paper ID is 048, and our paper title is Detection of Eye Blink Using SVM Classifier. And this paper is guided by our Associate Professor B. Dinesh Reddy, and we are from Vignan's Institute of Information Technology. And coming to the abstract, uh, of our paper, the eyes are the most feature of our bodies because through our eyes only we can explore the world. And nowadays, due to the improvement in the technology after the lockdown period, and everyone is sticking to the digital devices, so there was a when people stare at digital screens for long periods of time, they develop eye strain and visual issues, which is known as computer vision syndrome. So the best way to avoid these problems through the appropriate preventive measures, such that we can give them the notifications or pop-ups to uh, to tell them that they have to be limit their usage of the devices. So to protect users from the disorders, we created a model that uses the Viola-Jonas method and the SVM classifier to estimate the user's eye blinking ratio. As a result, the proposed approach calculates locations of significance and another scalar parameter is derived ratios of the eyes, where we calculate uh, the ratio of the eye, whether it was closed or opened, using the facial landmarks, which were defined by the 6 points, which can be used using the DLIP function. that categorizes each frame's eyes opening. Finally, in a limited temporal window, eye blinks are recognized as a pattern of AR values using an SVM classifier. The user can be notified about this gadget usage based on the results of the eye blink ratio and gradually diminish his addiction to digital screens that affect his eyes. Uh, so the existing methods are, there were so many methods where they can detect the eye. Some of the existing systems are they're using someone are using the pixels to define whether using the pixels ratio they are defining whether the eye is closed or not, and uh, some other using the EAR values where they will detect the 6 points using the classifier. They will detect the 6 points of the eye, and they are calculating a ratio which is known as eye aspect ratio. Based upon they are fixing a threshold value for the AR value, and uh, fixing the frames of size of 3 or 4 to detect whether the eyelid is blinked or not. If the ratio is decreasing for a short period and again increasing, they taking this attribute and they are defining whether the eye is closed or not. But however, due to noise in a video stream or sub for facial landmark detections or fast changes in viewing angle, a simple threshold on the eye aspect ratio could produce a false positive detection reporting that a blink had taken place while in reality the person had not blinked. So we proposed a method where we incorporate the existing model where we calculate the eye aspect ratio, and then we have trained a SVM classifier by you. We propose a classifier that takes a larger temporal video of a frame as an input. For the 30 frames per second videos, we experimentally found that we have plus or minus 3 frames can have a significant impact on a blink detection for a frame where an eye is the most closed while blinking. Thus, for each frame, a 7-dimensional feature is gathered by concatenating the eye aspect ratios of its uh, previous 3 and the next 3 neighboring frames. So based upon the 7-dimensional data frame, the SVM classifier is uh, trained, and based upon the training data set, it will uh, classify whether the eye blink is happened or not in that particular frame second. So in our methodology, for the first step was to detect the face detection, which was done using the Viola Jones face detector algorithm. And for the eye pair detection, we used the iBug 300 W data set, which is a pre-trained model which comprises of 68 facial landmarks, which will give the facial landmarks related to the face. So using that, there were fixed facial landmarks related to the eyes, where the eye is depicted using the 6 facial points. So using that, we have calculated the eye aspect ratio, because the horizontal distance between the distance between the horizontal points will be fixed whether the eye is closed or not. So using the vertical distance between the points, we have calculated the EAR value, and then we made a 7-dimensional data frame, and based upon the class Y, because while we considering the data set, Ibling data set, they have given us at which frame the eye is opened or closed. So using that, we trained the SVM classifier, and we have based on the data frame, the SVM classifier finds the Y value, and if it was uh, blinked, it will estimate that whether the eye was blinked or not. Given an enormous amount of zeros in Y, the idea was to balance the dataset by picking a random sample of zeros equal to the number of ones for each move. The end result was a dataset with 5,000 rows. When we calculated, we have considered the two parameters. One is precision and recall. So we compared between SVM and the OpenCV model, which only considers the AR value. When it comes to the precision tells whether when the actually the eye is blank in the video, if our SVM classifier is detecting whether it was proving that the correct blink was estimated or not. And when comes to recall, it tells that if in the video, if the person is not blinking, then our video should not detect that it is not blinked. So the in recalls, we consider the false positives, and in precision, we consider the true positives. So comparing between the SVM and OpenCV, the SVM are giving a higher accuracy, So we find that AR thresholding behind both AR assumed classifier through database, the thresholding fails when a subject looks to the side or closes his or her eyes for longer than a blink duration. The SVM detector greatly outperforms the AR thresholding value. Based upon these values, we can deploy this to an app, and we can give permission to that app, and we can provide the notifications and pop-up windows. Thank you for giving this opportunity.
Hello.
Yes, sir.
So I have only one doubt.
Yes, sir.
So you have done your project on eye blinking, no?
Yes, sir.
So some people, there are some patients, maybe there are some people who are
Yes,
having this eye flickering problem.
yeah, yes, sir.
So how you are going to deal with that problem, people?
So basically, we would deploy this model to an app, sir. So the app will run in the background in the mobile phone or any Android device. So when the user will use the digital screen, the within a gap of 2 seconds, the number of blinks uh, per minute will be calculated using that app. So we can give an settings for them to fix the value, like if they are having heavy eye blink or a low eye blink, which is we can provide them the notifications for them, so they will get to know that what are their blinking rates. And we can also provide a feature where we can block the screen for a short time of period, so that they can again resume their work. We can provide a 30 seconds interval, so that a blank screen uh, will cover the phone screen, so they can have some type of rest for their eyes. So this is used for only preventive measure, so that they will be knowing about their conditions, and they won't violate violations.
Okay.
Sai, can I
Yes,
ask
sir.
a question to you?
Yes,
Sir.
sir.
Yes, sir.
Uh, It is a good for project work, I must tell you. But one thing is there,
Yes,
what
sir.
you explained just right now, what Sir asked you.
Yes, sir.
Okay, as a project, as a technique, you have used that thing to solve the solution, but to get the solution. But why SVM classifier? It is very old. What is the new thing you are doing in your work? And why SVM? Why not
So
some heavily loaded neural network or some other thing? So all these questions will come. And the question also will come, what is the contribution, special contribution or new contribution in your work from your side?
yes, sir. We thought that we can use. We had read some papers where
No,
they.
what you are thinking,
Yes,
what
sir.
you thought, what you are doing, that will not create any matter.
Yes, sir.
Matter will be what contribution you have, new
Yes, sir.
contribution you have, and why SVM classifier, that justification has to be there, because it is, it is very old thing. Okay.
Yes.
So now
Yes.
people are going for a new thing. So many new things are coming. So if you attended this conference just few minutes back, Dr. Sonia presented a very innovative thing which is not worked in India also. So what kind of innovation or new thing you are incorporating? So detection of eye blinking is not new thing. So many
Yes.
people has done. So what new thing you have added with that? As long as it is a research paper. You are telling, no, we are publishing, we are doing research, so that I am asking. If you are telling it is a simple project for my purpose, that is okay. There is another scenario it is. So you just think over it, okay?
Yes, sir. Definitely.
You find out these justifications, okay?
Yes, sir. Definitely.
Paper ID 94. Paper ID 94, a novel approach for health analysis using machine learning approaches. Ashish, you are given presenter rights. You can unmute yourself and you can present your paper.
Yes, sir. Thank you. Thank you so much for giving me opportunity. Sir, is it visible? My screen is visible?
No.
Just a second, sir. Sir, is it my screen visible?
The screen is visible, but the presentation was not visible.
Sir,
You're using mobile phone. Nothing is visible to the audience. You just shared some PPT, but it is not visible, not even readable.
Are you with a laptop or any desktop?
So with my paper ID is 41 with a title Prediction and Identification of Diseases to the Crops Using Machine Learning. So the title has been shorted, but the project is completely of 2 modules. So briefly coming up to the introduction, farming is one of the major sectors like that influences the country's economic growth, but India is completely different when it is compared to the other countries because India is completely known as the agricultural country and it with its vast agricultural sector. So, in country like India, where agriculture is the backbone, farmers are the backbone. But in present days, what is happening is interest in farming for the farmers is coming down. We can see that because a son of a farmer is not doing like farming in generalized cases. But when it comes to the other side of the scenario, where some of the people in the metropolitan cities are interested in terrace farming, like farming their organic fruits or something like doing on the terrace or in the garden or in the lawns. So what we did is we just made a website called CropWest, which gonna assist both of them in both of the scenarios. So firstly, I'll be coming it to the general person, like a person like me who is interested in terrace farming but has no knowledge. So what we did is I'll just can I exit the presentation and show you the website?
You can.
So this is the website that we have built. So we are providing 4 services. The one is crop recommendation. So firstly, this services recommends which type of crop to be cultivated in the best given conditions. So like we'll be asking the nitrogen value, phosphorus value, potassium, pH level, and they'll be selecting the state and city of that. So let's like So like depending upon the state and the city and the conditions, like and depending upon the soil NPK values, and at the same time the annual rainfall and the pH level in that soil, it will be recommending us which crop to grow. Here it is showing coffee, and at the same time we are giving another service, so which is a fertilizer recommendation. So this is not for the farmer, this is for the like a non-knowledgeable person, because we can't recommend a farmer to which fertilizer to be used, because they have been in that industry, like they have been pioneers in that field from the starting, because they had a lot of experience, in the generalized way they knows what is the fertilizer to be mixed and all. But what no one knows is how to use the fertilizer or how to make a fertilizer in an organic way. So this will be recommending the fertilizer best for the soil of a given crop in an organic manner. So even this requires the NPK values of the soil. So let's give some random value 20. Presently, we had only worked on these crops, like these only, and we can like expand to many of other crops even. So it is showing for this crop, the nitrogen value of the soil is very high. So it may rise to weeds. So we have to do this. We can give the manure or we can give coffee grinds and all, so that again the levels and all will be stabilized and the health of the crop is maximized. And the most important thing is whenever we as a common person does any farming, the most important thing is we doesn't know what's happening to the crop if if that's not healthy. We can't know which disease has been caught by that crop, and we don't know what to do and all. So that's what we are built over here. So whether it is in a mobile phone or it is in a website, we can just choose any, like we can upload this image of affected leaf of that crop, and if we say the product, it will be showing the disease, which disease has been caught and what is the cause of that disease. And at the same time we had trained this so well in such a way, like if you give it a healthy leaf, so I can see I have uploaded a leaf which is very healthy, or so if we show that it shows no disease, don't worry, your crop is healthy and keep it up. So this is completely when it comes to the technical side, that is for a common person who is interested in farming. But the most important aspect is for the how this can help to farmers. This can help to farmers in like two ways. It can recommend crop. It can like what crop cycle to be planted, because precision agriculture is going on trend nowadays in other states as well. So this helps in promoting the precision agriculture, and at the same time, it also helps the farmer, like what is the type of the crop and what is the cause of the like disease, to just say that. And what we have done is recently when it comes into the market, we can see that the most profit gained by any person is the retailers or the one like street vendors, where we go to them and buy the vegetables or the fresh fruits from them, so they are getting the maximum profit. But when it comes to the other side, the farmers, the one who are producing it, are getting the less profit. So this is the reason most of them are not interested in farming, because like they are not getting what they deserve, they are not getting the maximized profits. But where is this money is going on is the in between X amount, in which only 1/4 of the amount is used as a tax or as the expenses, but rest of the 3/4 is going into some other pockets, let it be any middleman, let it be any retailers. So if we had a solution, if we can make that 3/4 of the money just go into the direction of the farmers and let it be in their pockets, so they'll be enjoying the benefits, and obviously even they will go for that and they'll promote agriculture for their next generations even. So for that, what we built is an e-commerce website. So this is completely UI friendly. So first of all, let me say, if you are a buyer, general buyer, you will be clicking a buyer button. So these are the registered sellers over here. So this is a prototype. This is not the complete built one. So each and every registered seller will be having an ID over here. So if we just type the ID and if we submit, we will be giving the amount of like the crop he has, what is it like, what is of the description of that, and the product ID and the price and availability and quantity of that. So what is the reason of giving these many metrics is, if the crop is available, that is not enough, because if I am in some X place and if I have to go to Y place and buy that, in the if when I'm seeing in my mobile it is available, but the moment I reach the Y place, it is they says like it is not available, it is completely sold. So we can just know by the quantity. If the quantity is too less and your place is so far, so then you will come to a conclusion that no, I can't reach. Before the time I reach, it will be completed. So that's the reason we have kept it here, the quantity even. And just like it is an assistant purpose, sellers can write, this is like, it doesn't store anywhere, but you can write like a wish list over here. So now comes the seller part. So seller has two things. One, he can sign in and like he has to sign up. So when it comes to the sign up, we had provided a more secure way. We'll be asking only these metrics, but anyone can sign up by giving their like fault details and all, but they can't sign in because we provided a passkey over here. No one can get it except the farmers. So that passkey is completely generated in the database. So like just let me show. So this is the database where all the like permissions, let it be, each and every constraint will be provided over here. Then only these will be synchronized in this and they can log in and all. So I'll just give. So we can see here, we have a seller one over here, right? So I'll just log in into sellers panel. So now here comes the seller. So seller can add a product, update a product, and so adding a product, like let us give any product ID. Like,
Execution is not important, Lohit. So
okay.
you can skip the execution part. Anything you want to present, anything less part is there.
Okay. So what is the like? This is what it completely helps the two scenarios where it can help the person who are interested in farming. At the same time, it helps the farmers in generate, like no middleman is included in that. So we will be getting a doubt, how can farmers like operate the computer and how can they operate the laptops and all. But recently when we have seen some of the farmers, they are comfortable accessing YouTube, they are comfortable surfing YouTube videos, where in a study it was proven that 60% to 80% of the farmers nowadays are comfortable using the mobile phones. But for the rest of the 40%, we can assure by giving by creating some awareness, and at the same time we can provide the like we can form a syndicate. If they're in an area, we can form those all a syndicate and we can keep a trusty member who will be operating the website. So this is our this is the most like idea behind this, and we created this with a tagline just like to harvest your crops with the crop pest. So when it comes to the flowchart and module, so here it comes. So here is the website, whether he'll decide whether where he have to go. If he goes for the crop based suggester and have to upload the soil values, so those will be given, I mean, like generated into a database, like they'll be kept into database, and from the database, the complete values will be processed with the background algorithms and all. And after processing the data, it will be displaying. Even same for the buyer and seller, but when it comes to the buyer and seller, there is no processing of the data is needed. It is only just retrieving the data and adding the data and deleting the data. So when methodology and algorithms, for the second module, there is no algorithm needed because it is completely a web-based application. But when it comes to the first module, which has three things, that is crop recommendation, fertilizer recommendation, and crop disease prediction. So for that, we had we
Please
had
conclude
used
your presentation.
yeah. We had tested on several algorithms with the accuracy, and we came with this decision tree is giving this much, and navy base and random forest is giving this much accuracy. So this can be further improved with certain metrics which we had mentioned in the paper. And thank you for giving me this opportunity to present you my project.
What are you doing now, Lohit?
Presently, I'm working as a software support engineer in Amazon.
From where you have been graduated?
Vignan's Institute of Information Technology, and this project is guided by S. Nagamallik sir.
So, do you think this is the this type of facilities or software or work is not available in the market?
No, sir. The whole solution, even the disease prediction module may be available, but not with the many crop features. But the rest of them are not completely available.
Whenever you will develop something, maybe available, whatever, I don't know, all these things will not work because you have, when you are presenting something that should be very innovative. Idea, innovative, what idea you told, that is acceptable. But the way you found the solution, that has to be innovative as well. For
We
that,
don't have an all-in-one solution where we can cater all the things at a single stop. Until now, there is no solution, sir.
for that, you have to go through with the review part. What is available currently and in what extent it is available in the market. How it is using by all the farmers or in the market. So
literature reviews.
Without that, you cannot suddenly can do something and it will better than this. Because one in the slide number 7, you claim that your thing is compared with many algorithms. This many algorithms is very different kind of statements. Okay.
Not compared with different types of algorithms, sir. We had built them using different algorithms, but the one there are 2 algorithms which gave the maximum accuracy.
What is the algorithm name? Can you tell me?
Yes, sir.
Can you tell me any algorithm name with which you compare?
Decision tree. Decision tree we have used, and we had even used SPM.
That will not work, decision tree. You tell me some recently used algorithm. That you tell me. Which is available in the market and the product is popular. Have you studied that? So my advice is that you are already in the software. So
yes, sir.
My advice is that you go through with some recent studies and modify the paper more and go for some other additional publications on it. Okay, so that will be my advice. You talk to your guide also. Dr. Malik is a very big person, I know, so he can guide you nicely. What I believe. Okay.
Yes, sir. Sure, sir.
Okay, sir. Thank you, sir.
Thank you, sir. Thank you for your valuable feedback.
Paper ready 44.
Am I audible, sir, now?
Yes, sir. Perfect. Audible.
Okay,
you can share
okay,
the screen.
Okay.
Notice how many paper left?
Is it visible, sir?
Naresh, can you hear me?
Yes, sir. Yes,
how
sir.
many paper left?
2 more, sir.
Okay. So please tell them to do it quickly.
Yes, sir. This one and one more. Just 2, sir.
Okay.
Okay. Sir, you please start your presentation. Stick on to the time, 8 minutes and 2 minutes per query, sir.
Okay, okay. Sir, am I audible, sir? Paper
Yes,
47?
sir. Yes, sir. Yes, sir.
Sir, our screen is visible, sir?
Yes, please
Okay. Can I go ahead?
go ahead, sir, please.
Okay. This is Dr. Mohammad Abdul Maqid presenting a paper on an empirical study of CNN deep learning models for detection of COVID-19 using chest X-ray images. In this paper, these are the content of the paper: introduction, material methods, experimental results, conclusion. Next, introduction. As we are aware that COVID-19, due to the emergence of the COVID-19 in 2019, there are various effects that have been happened worldwide, and accordingly, research is also happening based on the different data and different modalities of the research is carried out. One of the modality that the researchers they have started to carry out is using the chest X-ray images. RT-PCR test is one method to test whether the person is suffering with the COVID-19 or not. But there are also some research they are going with this photograph. RT-PCR. Compared with the RT-PCR test, they are going with some chest X-ray images. So there are some notable works that I have given in the introduction part. Okay, then going to material and methods. In this session, we'll outline the data set selection and the model formulation that we have done. As we have used the deep learning methodology, what is the model formulation and what are the database that we have used for the chest X-ray images that we are presenting here? So we have used the grayscale images, and the data set is taken from a GitHub library. We have selected 1800 images. And from that we have used some pre-trained model. Actually, what we have did is we have applied the convolution neural network, and we have applied the transfer learning methodology, and we have used pre-trained model, and we have also proposed to develop or to modify the pre-trained model by adding few more layers. Okay, so the pre-trained models, CNN model that we have used are nothing but the MobileNet, Inception v3, ResNet 50, Exception, and DenseNet 121. These are the notable and the current pre-trained CNN models that are exist in the research. So with the model formulation, first of all, the CXR images that are nothing but just X-ray images are subjected to the CNN model, and the feature maps are generated based on the convolution layer, pooling layer, max pooling layer, then ReLU activation function, and the dropout layer. So we have accumulated all the particular model formulation steps that we were doing, that we have done in this particular model formulation. So we have applied the convolution filter, then we have applied the max pooling and ReLU activation function, then we have used the dropout layer, then we have applied the a final dense layer with soft max activating function is also applied. This is nothing but the flow chart of the algorithm that we have used. We have what we did is we split the data set with 1800 images into training data and testing data. 80% of the images are considered for the training, and 20% of the images are considered for the testing data. So if you can see the flow chart, we have convolution layer, 3 convolution layers, 3 max pooling layers, 1 dropout layer, 1 dense layer, and that we have selected. And if the binary classification we have considered for the classification detection of the COVID, 0 if it is coming of the output for the by classification, then we have considered is for COVID, and 1 is for normal. And we have also considered some evaluation parameters like accuracy, recall, precision, and F1 score. Now coming to the experimental results, the CNN models, the pre-trained models we have applied, and 80% are used for the evaluation and training, and 20% of the images are used for the testing data set. And we have used the Python open source is Keras is used, and TensorFlow is used as the backend. And we have used the Google Colab platform for implementation of the particular code. For the evaluation parameters, we have used the confusion matrix for the calculation of the evaluation parameters, and like a recall, precision, F1 score, accuracy parameters are calculated. Now we have compared the different models based on these parameters, and we have come to a conclusion that DenseNet 121 model is giving the highest accuracy and with good precision, recall, and F1 scores compared to the other 4 models like MobileNet, Inception, ResNet 50, and ExceptionNet. Now we have also compared our model result, the proposed model result, with the few available notable work from the literature, and we have also given the accuracy plot and training plot. accuracy plots and the training plots for all these particular models. And we have calculated these graphs, or we have performed this experiment for 10 number of epochs. So the graphs are plotted for 10 number of epochs. We have given the graphs for accuracy loss plots and accuracy plots for all these particular model, like mobile net, inception, and DSC.20220720.O.Session1.3 and exception. Okay, so we can see that the DSC.20220720 is having the highest accuracy curves and the lowest loss curves. We have also used some testing images for detection, whether it is detecting COVID as true detection or not. So if the value is coming as 0 and detection is also 0, then it is detecting as a COVID-19 correct result. Where value 1 it is coming and in the detection is also 1, then we can say that the normal image is given and the detection is coming as 1 for the patient. But if the result is something like 0 and 1, then we can say that the result is not correct. So we have also given a comparison of some notable work with respect to the precision value, and we have checked out that some notable work is also having good precision score, and I mean comparatively we have also a good precision score with these other methods. Now coming to a conclusion, what we have did is we have used the CXR images, chest X-ray images, which is also one of the modality of testing of the COVID-19. And a larger data set is we have taken, because other notable work, they have also done the same thing. I mean, and what we did is we have taken the new models, CNN models, and we have tried to modify the new models, and we have proposed, and then we use a transferring methodology with some pre-trained models. And what we got is, we have achieved a good accuracy result for a DSC.20220720.O.Session1.3 modified model. And we have also given the confusion parameters. And this empirical study will suggest that there are possible application of the deep learning technologies for early detection of the COVID-19. These are some references that we have taken. Okay, thank you, sir. Am I audible, sir?
Yes, sir, you are audible.
Okay.
Sir, just if you don't mind, can you go to the first slide, sir?
First slide?
Yes, sir.
Okay.
Just a minute.
This one?
Wait, please. Wait.
Okay.
So the work, what I understand, what data set have you used here?
We have used the chest X-ray image data set, sir.
But now the thing is that the similar work is there in USA. They are working on that, and they got very good result. And now they are using also post-COVID situation. So your work is good one.
Yes, sir. Thank you, sir.
If you just go through with that work also, that again they use the TensorFlow and TensorFlow with Keras they used, and they got very excellent result. And all hospitals are using that one. If you
Yes,
go
yes, yes,
that,
yes, sir. Yes, yes, sir.
if you go through with that, it will be good. If you want, I can share that thing also.
Yes, sir. Please, sir.
Touch with me.
Yes, sir. Please, sir. I'll be grateful, sir.
Naresh, are they access the chat box, Naresh?
Yes, sir.
Okay,
Everyone can access chat box.
Okay, so I'm giving into the chat box. Please check it. I think your work can be improved more. What I feel.
Yes, sir. Okay, sir. You want me to share the PPT?
The PPT you please share with Dr. Naresh.
Okay, sir.
And the link I forwarded you.
Okay.
So you please, it is a full package, developed full package with all the detail and the source code. So you can skip and you can improvise your algorithm to get better result.
Okay, okay, sir. That would be nice, sir.
I already shared it.
Oh, yes, sir. Yes, sir. I have taken, sir.
Okay, that is all about from my side.
Yes, sir. Yes.
Tirupati sir, any questions from your side?
No question. No question, sir. Thank you.
Okay, sir. Thank you, sir. Thank you. You can stop your presentation.
Okay, sir. Thank you. Sir.
Paper ID 44.
Thank you, sir.
Paper ID 44, please raise your hand. Paper ID 44. Pulse-based smart electricity meter using Raspberry Pi and MEFN by Ishwar Abhishek Tadipatri.
चलो देंगे अपन
Sir.
I thank all of you for your active participation in this international conference. I hope you enjoyed the program. I would like to thank all the keynote speakers, Dr. Kuder Altangal, Professor Jose El Senor, and Dr. Jabale Sonia for sharing their valuable thoughts on their area of expertise. And I also thank the management of KLU for providing the resources for smooth conduction of Smart DSC 2022. Thank you all. We will meet tomorrow as per schedule.